All right. Hello, everyone. Aloha. Thanks for being here, watching my talk. It's a shortcut to the bypass road. The story of this, like a presentation, started from research that started from like a client request to do a red teaming engagement in his corporation. And like one of the things they used was shortcut, and like since pretty much like we don't have like a much let's say initial kind of payloads to detonate in macOS without like you have like a 0 day those days, mostly for a phishing campaign. So I took like a hit to try to find something in shortcut, since it was something that the users are already like familiar to use, and like we could potentially convince them to install something like that, and see if we could kind of like get code execution through that. And that's the story of this presentation. But before we start, like I want to thank you, Objective-C Foundation, and Andy and Patrick. You guys rock. Thanks for creating this conference. Let's keep running it, so it's amazing. Now I finally understand why everyone that comes to this conference loves it. Besides like the beautiful view of like Hawaii, and the energy of the conference is pretty amazing. And I'm a first-time speaker, so please be kind with me. So let's go. So a little bit about me. My name is Marcio Almeida. I'm Brazilian, but I relocated to Australia. I have been 10 years already. And I'm a co-founder and technical director of Tanto Security, a small boutique pen test company in Australia, based in Melbourne. We do red teaming, kind of engagement pen tests. So I don't do much like of research, like as most of people that is here. Like I stumble like in this vulnerability, trying to find some kind of like entry points to help in engagement, and that's what happened. And here is my social media stuff if you want to get connection with me. And also there's my GitHub. I have like some other stuff that I published there from past years related to offensive pen testing stuff. Cool. All right, so the outline of this talk, basically, we're going to talk a little bit what's the shortcuts application, if you guys don't know yet, but I assume most of people here know what the shortcuts is. And then we'll explain the vulnerability itself and how it can be used to share with other users and then attempt to attack them, and the patch applied by Apple, and then our final considerations. So what is shortcuts? It's pretty much like a program that allows you to automate tasks with actions, okay? An action per se is just like a building block of a shortcut. So what it means, like for example, if you want to convert a PNG, JPEG file to a PNG, actions would be open a file, and then you point it to a image that would be like an image JPEG, and then use another action there that probably be like a convert that image to PNG, and then you have another action to save that file to a specific directory or path that you want to save it. So it's like pretty much like a video game kind of thing, like a construction by blocks, so just like a drag and drop blocks of actions, and you can entwine them to execute some like a full chain action, okay? And it also can be shared with other people and installed when it's proper signed. In the past, it basically could be installed and shared with people without signing by Apple. Now, Apple kind of forces you to send a copy of your shortcuts to them, and they sign it for you, and then you're like free to share with wherever way you want to share with other users. Just put it a little bit higher. And yeah, and it also has a marketplace that basically everyone that creates a shortcut can share it there, and people can download like shortcuts from there. That's like some of them like pretty useful. A lot of people use that to actually do proper work and automate a lot of the tasks. Shortcuts also has like a client application. So in essence, as everything in macOS, a shortcut is nothing more than another plist file, right? That contains a list of the actions that it's allowed, and the application going to interpret those actions and execute everything that is defined there. So if you want to actually look inside of a plist. That is a way that I'm going to show to you guys later how you can extract a shortcut, because usually it's created inside of a database file, inside of like a SQLite file. But also there is a way that you extract the plist from there, that when you share the shortcut, it creates a link, and then if you pass it through burp, you can analyze the API request response, where you have like the links for you to download the signed version and unsigned version of this file. And with the client app, you can run, list, view, and sign a shortcut that you modified and created it manually, okay? Now let's talk a little bit of the protections and why this talk happened, right? So shortcuts are pretty powerful, right? You can execute code, you can execute commands, you can do pretty much everything that a user could do in the operational system. However, Apple, knowing that, they block by default the execution of scripts, because it will be pretty much easily just go there, share something that runs some code in your machine, and that's it. So if you want to create like a shortcut that actually allows you to use those powerful functionalities, you actually need to go to Advanced, and then enable it, and then you'll be able to do this kind of thing. And besides of that, also, it avoids you to share large amount of files, delete large amount of files without like a confirmation, and yeah, pretty much that. Also, the first time that a shortcut requests access to a folder, for instance, like a home folder, it will pop up like the macOS privacy control will pop up asking the user for permission to allow that to happen. However, that's like a pretty common permission ask for pretty much like almost, I don't know, a lot of like shortcuts that I tried that are like legitimate, they ask for this kind of permission to access the download folder or image folder of a user and so on, right? So the user, he's like used to receive this kind of pop-up to allow a shortcut to take an action. And here in this presentation, we actually want to attempt to bypass the most let's say, important protection in the shortcuts. That's the ability to execute code without the user going there and enable this functionality here. So for you guys to have an idea, these are some examples of like interesting actions that we can use to abuse shortcuts. Here we have like heaps of like actions that allows you to manipulate files. So you have like a file, rename file, save file, delete files, move files, append to text, and append and open file, and we also can open and quit applications, right? So we're gonna see if we're gonna talk about all the actions that we can do in shortcuts, it will take like, I don't know, maybe 1 hour just talking about them. So we're just gonna focus on the ones that we use in our proof of concept, and where those ones that you can see here in the screen, all right? So what's the main idea? We learned that like to execute scripts, they are like blocked by default by shortcuts. And however, we can read, write, move, rename files, open applications. All of that don't require any kind of special approval by the shortcuts application. What's pretty powerful. So can we use maybe using these primitives to get code execution? So my idea was, as a pen tester that does like a CTF and kind of things to get code execution, my idea was like, okay, can you potentially write a public key to the authorized keys file? Maybe can I write a cron job? Or potentially can I write like a config shell file inside of the home user directory and open the terminal app? What will triggers the code that I put inside of these files? As example here, like since macOS use like a Z shell now as default, if we can create any of those 5 files inside of disk, or if they exist already, and you can append to those files and open terminal, we'll be able to get code execution. So that was the main idea, and this is what happened. I just tried to append, play this. So the main idea was this, just list, the file do not exist, then I create the file, and I just run and got code execution. The main idea here was just like I put a curl there just to show that could be basically anything that I can download. As people said here already, the curl has the ability to simply say hi to gatekeeper and bypass everything and download basically any malware that you want will basically straight go away. And from there, your imagination can fly, and the only thing that I use here is just to pop a calculation for the proof of concept. Cool. Append's nice, work, that's cool. However, let's see what happens when this file does not exist, right? So here is the same POC by running to show that the file does not exist in disk already. And like the .text do not exist too. When I run the POC, nothing happens. However, when I list, I see that like for some reason, like shortcuts always appends the .text or .json or .whatever. That's basically the context of the file, of the content that you manipulating there. So you see like the text block. So it always will append the .text information in the file. What's pretty sad, because unfortunately it limits a lot the targets that we're trying to attack, right? Unless, like, let's say, I guess like there's some programs, maybe like iTerm 3 or iTerm 2, some of them like automatically create those files for you in disk already. So when a user that already installed those apps, it automatically creates those files. But that's not the most common to the normal user, right? Like, let's say, people that are trying to fish, that they work, I don't know, in marketing, they will not create or use terminal too much, so they will not have those files created in the disk. And unfortunately, that limits the attack a little bit. And then we need to do a little bit better. Can we actually create a full payload that we always work in everything? So that's what we tried. And this is the payload that I came up with. Basically, it's the same start. And then we save temporarily to a file. The name will be like xxxx. And then I use the set name to modify the name of the file. And after that, I move it. And then the move action has like a flag that allows you to, in the set name, there's like a possibility to remove the extension of the file, right? So if you just add the .zprofile, zshelrc as is shown there, then the file will be saved without the extension. So when we play here, so I'm showing here now that the file does not exist in disk again. And we get code execution successfully. So in this case, it always will work because the file now, even when it does not exist in disk, it will be created, right? And you can be pretty creative here as well. Like, for instance, you can modify your payload to hide the terminal application and will not show up. You can, abuse everything that you can imagine in shortcuts to make it like a lot more silent and, working better. And yeah, so that was the final payload, and it should work in any scenario. What's pretty cool. And bypasses the .text extension limitation. And the only thing that I did was like a save a payload, rename it, and renaming and removing the extension. To share a malicious payload and sign a shortcuts, basically you get your final payload and clicking the share button here. And after share, basically you get a shortcut if you navigate to the browser. The cool thing is if you intercept that in burp, you can see the request that is sent, and you can actually download the file, the payload file. And you have like a signed version and an unsigned version as well. And the cool thing is once you download this file, you can embed it in anything. You can embed it as an attachment of like a Gmail or sending it via text message or whatever. And the cool thing, at least the last time that I tested, like the extension was still not being blocked by Outlook or Gmail or any of those apps. And no antivirus applications that also scan emails for malicious files was detecting that as a potential malicious file for the users as well. Here's like a pretty lame example of a phishing attack. How would be like for the user when they click to download the file. They download. And once they open the shortcut, it triggers to open the shortcut application. They add. They just need to run. And then it asks for the permissions for the first time it run it, and get code exec. Cheers. Cool, so I submitted that to Apple, and that was the timeline of submission. Took some time for them to get with like a solution to the problem that I'll show to you guys in a minute. And unfortunately, by the rules of Apple bug bounty program, anything that requires user interaction, they do not offer any kind of bounty. That's a shame, unfortunately, but it is what it is. At least we have like a new cool technique to potentially like using right team engagements. And the patch was basically that. Now, it still works. The same technique that I showed you guys work, but however, now the alert the user saying the shortcut is trying to modify a shell configuration file and asks you every time if you want to continue executing that. So basically, that is the patch here, running. So once you run it, it complains, but it still runs, works normally. So I still think that's much better than like a completely blocked, as was before, right? You can convince the user to click it, maybe. However, this patch forgot a really important thing. Remember when I said if the file already exists in disk and you append to it, would gonna work? Yeah, they didn't patch this one. So if your file exists in disk and you go there and append, they forgot to apply the patch to the append action. They only modify the move in the rename file as far as the record. Those are like the only ones they patched. And then, so if you want to use the append to file action, it still works. However, it's dependent of the file already existing disk to get code execution. Yeah, so it's a limited attack scenario, but still works. And as final considerations, shortcuts is like has a massive attack surface. I think I barely scratched in the vulnerabilities here, and together with like this vulnerability, when I reported, if you go to the patch notes, you see the anonymous reporter that I don't know if it was like maybe an Apple employee or someone else reported like a bunch of other vulnerabilities in shortcut. I guess it was like around 8 CVs, only in shortcut, all packed together. What's pretty interesting. Some other things that like as a note, like the get contents URL and the OpenX callback URL, you can use any kind of like a URL handle protocol. So for instance, you can use file, column, // you write localhost / ... and then you put any path in the internal system. We're going to be able to access files. That works even in iPhone as well. So for instance, if you use that in your iPhone to access the etc passwd, you'll be able to access actually the etc passwd of your iPhone. Potentially, you can use that to access other sensitive files, but needs like a further investigation. So there's another note if you guys want to investigate that, worth the investigation. And that's potentially other easy bypasses like this one that I stumbled by just accident and using an idea that people use in CTFs and and in pen test engagements to get code execution. So if you investigate, you can also probably find something like that as well. And that's it. Thank you a lot.